Hello everyone, I'm going to show you how to fill out checkpoint 2, analyze and model your country's growth. You should be on part 1, the tab at the bottom. First is you want to collect your country's data from this spreadsheet that's located in B1. My country that I'm going to model is Eritrea. So for myself, I'm going to click on the data in B1. It's going to open up to another spreadsheet. It'll take a moment to load. Once it loads, go ahead and scroll and find your country. I'm going to scroll over to the E's and stop right there. Got to go back. Highlight the country's population from 1960 to 1990. Highlight it and press Control C, that is to copy. Go back to the tab of checkpoint 2. Click on B4, that light blue square, and you're going to just press Control V to paste all of your country's data in that column. Move over to column C. This is where you want to calculate the absolute growth. So like how much are you adding from each year, so year to year to year. If I want to figure out how much I'm adding or growing by from 1960 to 1961, I want to calculate the difference between those two values. Click on C5, press equals, and you're going to take the population in B5 minus the population in B4. And that'll give you the difference, and that's how much is growing from 60 to 61. You can keep doing that by hand if you want, but that's going to take a while. So I could do B6 minus B5, and then I could do B7 minus B6. But to save time, if you click on one of these values that you just calculated and you drag down the right-hand corner, it does it for you automatically. Next is that you want to find the average absolute growth. So you want to take these values, and if we had all day, we could add them all up and then divide by 30, because you have 30 values. A faster way is to tell the computer that you want to find the average of cell C5 to cell C34. Here we go, equals. Type in average, parentheses, C5, colon, C34. Enter. That is your average absolute growth. This is the number that we're going to use for the slope when we create our linear regression line in y equals mx plus b. Move over to column D. Next, you're going to calculate the percent growth. And by the way, in case you ever need help with the codes that I'm typing in, you can click on the arrows between E and H to expand those two columns. And it was hidden for you, but this is like a little cheat sheet, so you can refer to these to help you out. All right, to calculate percent growth, there are a couple different ways you could do this. If you want the percent growth in terms of what like you're multiplying from year to year to year, to see how much you're growing, you can just say equals the population from 1961, so that's B5, divided by the population in 1960, so B4. Percent is some number out of some number, so this is going to be a division. And when you divide those two, you see that you are basically growing by 102.38% from one year to the next. Again, you can just drag down the right-hand box in that cell and take it to cell D34. Let go, and all of your growths will be displayed in that column. So again, this is your absolute growth from year to year to year. It looks like my country doesn't have any number below 100%, meaning there are no years where the population decreases. Each year it's increasing just a little bit. All right, so now I want to figure out on average how much is it increasing as a percent. So you can do the same thing you did in column C for cell C35, except this time it's average equals average parentheses D5 to D34. So D5 colon D34, close your parentheses, enter. So on average, my population growth is 102.86%. You are now done with part 1. Move over to part 2. In part 2, there should be a bunch of data that's already there. This is like default data. We're going to go ahead and insert our own data in column C. So again, this is not supposed to be your country. I don't know, maybe it is, but I know it's not Eritrea's population. So again, I do have to do some copy and pasting. Oops. All right, when you make a mistake, you can just press Control Z and you can get back what you accidentally deleted. So I'm going to type in Eritrea for my country. And now I want to get the population from tab 1 over here. So if I click back to part 1, I can highlight everything that's in column B. Population from 1960 to 1990. So Control C and then hit Control V, start off at C2, Control V, and now there's Eritrea's population. Notice how the population, the original population in 1960, so where you're starting, initially is like 1,404,810. That number is here and here and here and here and here and here. It's all over here because you have not inserted any formulas, any like growth numbers in H1 or K1. And that's what we're about to do. So these numbers should all be repeated so far. All right, so you're going to go ahead and type in the absolute or the average absolute growth, or maybe it's DK, most of you should have growth, of the population every year. So this is going to be the slope that you're calculating. So on average, we already figured out that my country was growing 62,258 people per year on average. I'm going to type that number, 62258, right here. All right, if you want to include a comma, you can, but it does it automatically for you. And I'm going to go ahead and type in the number for K1. Now this is a little tricky. Before I move on to K1, I just want to point out one thing. I'm going to delete this number, and I want you to notice how right now all of these numbers are the same. But when I insert that number, what was it, 62258? 62258. When I insert that number and I press enter, all of these numbers are going to change, and it's going to be adding this value from year to year to year. So watch. Enter. Now, click on cell D3. Do you see how in the upper left-hand corner it's giving you the code? It's telling the computer to take the value in D2, so this guy, plus the value in H1. But the reason it has the dollar signs around the H is because of what Mr. Miller talked about in his screencast video if you watched that last class. And you'll notice from year to year to year, it's just adding 62,258 from this year, then this year, and it keeps adding. It's your constant rate of change. So if my country was growing exactly the same rate every year, this would be the population. Okay, but obviously this is real life. There's no country that has a perfect constant rate of change from year to year to year, but this is how we are going to model that change. This would be our slope in H1. All right, and let's go ahead and define our variables actually. So we'll worry about the green stuff in a second. All right, X is going to be the number of years past 1960. Remember, that's defined right here. I knew that because it was in cell A1. And then your Y variable is obviously your output, it's your population. So you're going to figure out what your population would be, what you would predict it to be, by inserting X. So whatever number of years past 1960. So here's the formula, and I'll color code it for you to help you out a little bit. You know your formula, if it's a linear equation, is going to follow this format. Y equals m times x plus b. And I'll go ahead and use parentheses just to make it a little bit more clear for you. All right, we know x and y are my years since 1960 and my population, but my m is my slope. The slope I told you was in H1. It's your constant rate of change or your average rate of change. So please don't use commas. It is an equation. And if I highlight that in red and I highlight this number in red, hopefully you can see that I'm just inserting h1 in for m. All right, my y-intercept, well, think about it. If you put in 0 for x, because like 0 years have passed since 1960, you're obviously talking about the year 1960. So that's this value right here. Eritrea had a population of 1,404,810 people in its country in 1960, which means when 0 years have passed. So you're just typing the country's initial population. And I will highlight this and let's go with green. All right, hopefully you can see where I'm getting that number. All right, everybody, ooh and ah, isn't this fun? Beautiful, you have a nice y equals mx plus b equation. That's a model. You're going to use that model to make a prediction about what your country's population is going to be in 2012 and 2050. So before we do that, hop over to this cell. And remember, in K1, you want to write the average percent growth or decay. Now, the annoying thing about this is that you don't want to write it as like a 102.86%, because if you do that, then you're going to get a really, really large number, because what you're doing, look at the code here. Do you see how the code says 1 plus the value in K? So the computer's already programmed to compensate for the whole, like the 1 or the 100%. So this really needs to be 2.68%. And I think my percent sign didn't automatically show up, but it should automatically show up. Okay, there we go. 2.68%. My formula, my exponential formula, is going to be in y equals a times b to the power of x. To get that little caret that I'm typing, you just have to press Shift 6. All right, A is my initial population. I know my initial population. I can steal it from here. My initial population is the 1,404,000, that number. All right, I will color code it, even though green on green is going to be a little harder for you to see. All right, and then my B. Well, my B would be my rate of change. Okay, so that's my grow by number or my multiplier. Now, don't write 2.68, don't write 2.68%. Think about it. You are multiplying by 1 to maintain the previous population from the previous year. And then you're going to be multiplying by 1 point something. So the way I think about it is the number that goes in those parentheses essentially is this number, right? 102.86. It's just that number divided by 100. So if you want to get that math, if you don't know what that is, which you should because you're in 9th grade, but if you want to double check, you can do that. All right, all I did is I just did 102.86 divided by 100. So that's 1.0286. Oops. All right, let me go back to tab 2. Again, that's 1.0268. I think I was misspeaking there. Okay, I think I typed in the wrong number. It's 2.86, not 2.68. There we go, 86. All right, and then you're done with your models. Do yourself a favor so that you can be set up for more success. Go ahead and add 2 columns. So you're going to click on row K, and go to Insert column right, and just insert one more, insert column right. All right, and then you can highlight those cells, make them white again, and go ahead and copy this box, paste it to the right, copy this box, paste it to the right, and I can expand these to make it a little bit easier to read. There we go. All right, one more thing, go ahead and highlight chosen and just write linear and do that here. So it should be linear, linear, and this should be exponential, exponential.